I think.
So, ladies and gentlemen, good afternoon. My name is Rasmus Lindholm. I work for ERTICO ICS Europe, and I'll be moderating the webinar today, so at least for the next hour. Welcome to the webinar on the project MOBiNET. We will try to walk you through the different elements of what the project is about and what the outcomes are. But first, quick introduction of the agenda itself. I will give you first a very brief overview of MOBiNET, the platform, public authorities and cities in particular in focus. Wen Xu from Volvo will show you a particular use case, more specifically the non-stop truck. Robbin from IMTECH will do the same, show you another use case, the green light optimal speed advice, the GLOSA, in terms of how to increase the traffic flow in your cities. Julie Castermans, also here from ERTICO, will show you a bit about what MOBiNET is showcasing at the ITS World Congress in Bordeaux, which will happen in 2 weeks' time. And then I will conclude with some of the next steps in terms of the project itself, and maybe most importantly, how could you engage within the project and activities, should you choose to do so or find it interesting. And at the end of the webinar, we'll have a short Q&A session. So just some housekeeping rules in terms of the webinar itself. On the right-hand side, you'll find a menu that you can also collapse if you want to. If you do have problems with the audio, you have to click on the audio setup. And by clicking on View in the menu, you can adjust the different views of what you have. Like I said, in terms of the questions, we will save the questions until the end of the presentations and do a short Q&A session. So let me start by giving a quick overview of the MOBiNET project. 1 second, we'll make sure you can see the screen. Voila, here we go. So MOBiNET is an EC-funded project under the old FP7 framework program from the Commission, and the core of MOBiNET is to create a European-wide e-marketplace of mobility services. So basically, we want to create an e-marketplace, cloud-based, of mobility services in Europe. Apps, services in general, you know, it's a jungle. It's very difficult to find, both from an end-user perspective, but also from a business perspective. If you would like to enhance your services, extend your potential customer base and usefulness of your services outside local areas. We also fully recognize that for public authorities, local regions, and also nationals in the whole sphere of open data, innovative services, mobility as a service, and other buzzwords that are floating around at the moment, it's very difficult to engage with the potential developers and service providers that could potentially use the transport data made available by the public authorities. And hence, you know, fostering innovation in terms of new ideas popping up. So MOBiNET is trying to solve those issues. We are trying to make it a place where both public authorities can publish their data and see the innovation that are coming out of it. We're also making it a place where content providers, it could be road operators that also makes traffic information available from the road network, service providers that are publishing their services itself, for enabling their business and enhancing their service. There's also a link to the end user through an app directory or service directory, as we call it, which is basically the place where you can do a search for the different services that you are looking for. And finally, what we've also developed in the context of MOBiNET is a set of components for the developers that they can use, so that if they have a good idea, they don't need to worry about how billing mechanism is working. They don't need to worry about how identification manager is working, etc., etc. So there are also a set of tools that would be available for developers should they choose to make a new service or a new app for end users using both existing services and data available. So moving on from there, just a few facts and figures. Like I said, it's an EC funded project under the 7 Framework Program. I'm the coordinator. It runs up until August next year. Some of the partners in the project, as you can see in the screen now, comes from quite a lot of different industries, which is also essential. It is an FP7 research project, so the research community in this is quite large, as it should be. Service providers is the other category where we have quite a lot of partners in, and again, a lot of it is related to developing services and for service providers to find each other. We'll show you some examples of that later. Hence the consortium looks like this. The components itself, on a very high level, the presentations could also be made available to you afterwards, so I'm not going to go through all of it, but what I wanted to highlight basically here are the three different things. On the left, you have the Mobi Agent, which is the interface to the user. Mobi Agent is an app you can download from an app store, or users itself, such as a professional users, also has a web interface, can look for what is available in the Mobi Center, which is what you have on the right-hand side. In the Mobi Center is really where you can find the services, you can find the data, and you can find the different components that's required to develop new services. At the bottom, you then have an SDK, Service Developer Kit, and you have a dashboard. This is basically the interface for developers into the Mobi Center itself. Now, in terms of validating the platform, in terms of making sure that the technical development of this cloud-based e-marketplace is working according to the needs of the service providers, we have also put together quite an extensive list of use cases, services, that are either being developed from scratch, or existing services locally that has been enhanced. You'll hear later on today 2 examples of that, which is the non-stop truck and the GLOSA service. But just an idea in terms of how it works. Parking, as an example, you have a local parking app in a city in North Denmark in Danish, and you handle your parking payments through that specific app. If you then go on holiday abroad, travel to Hungary, Italy, Greece, that exact same app as you have available locally in Aalborg would also be available, will also be functional when you're traveling, and you'll be able to pay for your parking in Greece, as an example. That's what MOBiNET enables. It enables the service provider for the parking app in Denmark and the one for the parking app in Greece to find each other through the Mobi Center and hence make an enhanced service for the user. In terms of coverage in Europe, we're trying this out in different locations. As you can see, it's quite a broad span. From Trondheim, Helsinki in the north to Trikala in the south and Vigo, London in the west. We're doing that because we truly believe that in order for something like this to work, we need a good European coverage. We assume that some of you have been listening to these webinars before, and a lot of you have probably been involved in EC-funded projects before, and some of you might be a bit skeptical in terms of what is actually the outcome of something like this. Our experience is that unless you pay a lot of attention, there is a high risk that what you're developing is going to end up in a 300-page final report, and it'll be stuck on a shelf somewhere. That's not what we want to do with MOBiNET. So, of course, it's a research project. The proof of concept is what we're developing from a technical standpoint, the cloud-based e-marketplace itself. We're using different services, also as proof of concepts, to demonstrate the technical viability of doing this on a European level. Equally, or maybe more important, because of the noise that we're making with an e-marketplace and because of the interest that we've seen in the market, both from the public authorities and from the industry outside the MOBiNET consortium, what we also would like to do is look at a more commercial side of it, because we fully recognize that the project will finish in August next year, and at that point we would like to have something tangible that we can continue to work on, continue to gain momentum around, so that we truly make this happen in Europe. Now, for that to happen, there is a lot of non-technical issues that also needs to be sorted. Some of them you have on the screen in front of you. We need to look at the business motivation. You know, for all these different stakeholders to be part of this, we need to be able to show what's in this for me. We also need to look at the governance of something like this. How is it actually operating? There are legal issues in terms of certification, etc., etc. Safety is one aspect, and for sure security, such as private data privacy. What do we do with all the end users' behavioral analysis and data that we will gather through the project and through a potential, wouldn't go as far as saying a commercial operation of any marketplace, but at least for someone to take this forward and making it happen in Europe. So I think the technical issues is something that we are proving. The non-technical issues is something that we have to pay very, very much attention to, and it's something that we in the consortium itself will come up with a suggestion in terms of how we foresee this happening. Of course, there the cooperation with external partners are extremely important, because what also tends to happen in projects like this is that the consortium becomes a big family, and we all tend to agree with each other, and sometimes it's really good to move outside our own consortium to have whatever developments we've been doing validated. Part of that validation, a huge part of that validation, is what's going to happen at the ITS World Congress in Bordeaux. But for that, I'll leave the word to Julie at the end of the webinar. So that was a high-level introduction from me, and I think the questions, like we said, we will save until the end of the webinar itself. So now that it gives you an idea of what it is that we're trying to do, what we would like to do now is dig into two specific use cases, starting with the non-stop truck from Volvo. And here, Wen is the person responsible for the development of the non-stop truck service. So with that, I would like to give the floor to you, Wen.
Thank you, Rasmus. All right. Good afternoon, everyone. My name is Wen, a project manager from the research department of the Volvo Group in Sweden. I would, in the following 50 minutes, give you a brief introduction of the non-stop truck service. Okay, now it works. Sorry for that. My agenda will start with a general definition of the non-stop truck. After that, I will show you a special use case and how the non-stop truck is supported by the MOBiNET platform. In the end, we will finish with some result from our practice earlier of this year. So let's start. So what is the non-stop truck? Generally, today, we all know that a good vehicle control stops all the trucks for a check for different purposes. It is rather important to have this kind of check, because the goods vehicles normally, if they are not compliant to the regulation, might lead to much higher costs or even cause serious damage to both the road infrastructure and the society. But this also causes some other problems. For instance, stopping all the trucks reduce the overall traffic throughput and also cause more higher energy consumption and carbon emission. For the logistics companies, they also suffer from uncertain amount of delay in their schedule. To improve the situation, Norwegian Public Road Administration, together with Volvo, have, based on the MOBiNET platform, developed a service called a non-stop track, or NST in brief. It is an open MOBiNET service, and the service allows trucks to automatically declare their status data or goods information to the public authorities in order for a clearance at the vehicle controls. In this way, unnecessary stops will be avoided, economic and environmental impacts will then be minimized. Here comes a special use case, a non-stop truck service for weight control. This diagram shows a typical setup of a weight control station. So how does it work? Start from the left. The red truck is approaching to the weight control station. Quickly, the onboard unit in this truck starts to communicate with the roadside unit that is installed along the road and is about a couple of 100 meters in front of the control station. So the identity of the truck and the weight information is declared to the control station. The control station will decide if a clearance should be granted or not. If such a clearance is received by the driver, he will be allowed to drive through the gate without being stopped. Otherwise, the operator at the control station will request the truck to stop for a manual check. The communication is accomplished by using a Wi-Fi variant for V2V and V2I communication. And the data exchange happens instantly. It works very efficiently. And of course, the underlying technical platform is MOBiNET. But why? Because as a pan-European mobility service platform, MOBiNET greatly extends the reachability and availability of a service. In other words, for the case of non-stop truck, any European public authority can publish their service to any users within the Europe. In this case, any truck owner within the Europe is able to consume or use the non-stop truck service and to share their data with any European public authority. Let's take a closer look at how MOBiNET supports non-stop truck. This diagram lists all the major components of MOBiNET. If we start from right, non-stop truck use the service directory to publish the non-stop track service, so it becomes publicly available. To ensure the data privacy, the identity manager will authenticate and authorize both public authorities and the truck owners. Thus, a secured end-to-end communication is ensured. The dashboard is used by the service operators to manage and maintain the weight control station and to operate the non-stop track service. At the last, MOBi agent is an Android-based runtime environment. With this, user-friendly application can be developed to use the MOBiNET non-stop track service from different nomadic devices. As a reference, a tablet application has also been developed for the truck driver to use the non-stop track service. If we take a look starting from the top, the truck weight distribution is first displayed. When the truck approaches to the weight control station, it starts to declare its weight data to the control station, and the app will notify the driver that communication is ongoing. The control station decides if a clearance should be issued or not. Depending on what response is received, the truck will either pass through the station or be stopped for further check. So what are we now? Earlier this year, we have completed the first road test at the Route control station in Norway. The self-declared truck weight is about 5% lower than its actual weight. The data exchange was finished at averagely 1 to 2 milliseconds. Those results are very good and also promising for the service itself. In order to better evaluate the system's performance, we plan to equip 4 more trucks next spring and pilot the service for 2 months. So this is what I have today. Thanks for listening.
Thank you very much, Wen, for the introduction of the non-stop truck. Without further ado, I'd like to move over to Robbin from IMTECH, giving us a rundown of the green light optimized speed advice, or GLOSA, as the acronym says. So Robbin, the floor is yours.
Yeah, thank you, Rasmus. Okay. In this presentation, I will start with a brief introduction on why GLOSA and IMTECH should be involved in MOBiNET and what the advantages are. Then I'll describe the service and follow with the deployment workflow and how to deploy the service on the streets. Then I'll go further in detail on the platform usage and describe the progress so far, and I'll conclude with a conclusion. So on the next slide, we see why GLOSA should be a MOBiNET. For IMTECH, MOBiNET is important because we are a technology provider and we implement traffic services throughout Europe. But interoperability is a major challenge for us to deliver these services everywhere, because data formats are different, and yeah, there are lots of challenges and differences in traffic light control, for instance. So the MOBiNET ecosystem should help us with this interoperability. I will show this later on why. The GLOSA app itself, we believe, is a good example for usage of MOBiNET because it can really exploit the flexible scaling up with the platform. And also the platform enables the separation of the different roles that you have in a chain to deliver the app to the end user. There is a data provider that delivers data from the traffic light controllers. Then there is a service provider who calculates an advice or some other inputs for the user. And then there is the app developer that shows it to the actual end user. So on the next slide, we see the description of service, just a basic principle of GLOSA. On the top picture, we see a car approaching a traffic light. You see that this car consists of a red, a yellow, and a green part. Well, the red part represents what would happen if the car didn't have any speed advice. The yellow part represents if there is only data available about when the light turns green, but no queue information. And the green one shows when there is also queue information. So then on the second picture, we see that the traffic light is still red, but the red car has already joined the queue and stopped. The yellow and the green car is still approaching. Then on the third picture, the traffic light just turned green. But because the yellow car didn't know or didn't get an advice about the length of the queue, it had to stop at the back of the queue. But if there wouldn't have been a queue, it should have passed on exactly at the moment of green. The green car, on the other hand, also had this information about the queue length and could therefore merge with the platoon just as the last vehicles are passing the stop line. So this is the general principle of GLOSA, and on the next slide we have some results. There we see that the GLOSA in real life, we had some previous projects where we analyzed lots of trajectories and we found an 11% reduction of CO2. But in simulation it's still kind of difficult to let simulated drivers behave really well. This is because the last part before you reach the stop line, you have to fine-tune your speed a bit, and this is hard for an automatic algorithm, but a real driver will not stare at his screen anymore to see what is the speed advice, but will just adapt himself to what he thinks is optimal, and it turns out that that is better than what an algorithm can calculate in those last seconds before passing the stop line. Also interesting is to see that for trucks the gain is largest. There, even in simulation, we get almost 11% reduction of CO2 emissions. CO2 on average is not such a big reduction, but the NOx, which is a harmful emission for health of people, that one reduces considerably as well. And I think this is also very important because the health of people in a city is an important topic. We also see as last point that the total delay of vehicles at 100% penetration reduces considerably, and this is because the traffic light control will not get like spread platoons of vehicles, but thanks to the advice, the platoons get more dense, and this enables the traffic light controller to have more efficient strategies that deal with denser platoons. What is also a point that we can see from this data is that even though there is a reduction of CO2 for any penetration rate, the total delay is actually sometimes increased when there is mixed traffic. So for 10 and 30% penetration rates, this may increase a bit because some traffic is slowing down because of the advice, while others that don't get the advice are trying to overtake those cars. So I would say that when deploying such a service, it's also important to inform the public that this service exists so they know why people on the road are driving slower. Then on the next slide we see a more architectural overview of the service. So we start with the traffic light controller on the top left. This one supplies signal states, predictions of the signal states, and queue and detector states to to give what was in the first description of the service slide. This last extra bit for the quality of the advice, so also the queue length can be taken into account. This goes to the roadside unit, which does not necessarily have to be on the road, but I'll get back to that later. This one calculates the speed advice and through standardized messages, which are formed by the SAE and ETSI. This can be communicated through two channels. One channel is directly through the air with the 802.11p network, but it's not always available. And this is where MOBiNET has a very useful service built in, which can be used by any service, not just by GLOSA, and that is a connection through the internet. And for this, the messages are sent to a back office through a secure environment so that people cannot easily access traffic light controllers on the street. We don't want hackers to deal with traffic light controllers. That back office sends it to MOBiNET's communication agent, and this agent makes sure that those messages gets to the vehicle units that are at the location for which these messages are relevant. So suppose we have the service running both in Spain and in the Netherlands. People driving around in Spain won't get speed advice for intersections in the Netherlands. And of course, there is a small range associated with each message, so you won't even get messages for the other side of the city, for instance, either. Then the last part is the app, which shows the advices to the user, and that makes the circle round. On the next slide, we have the first part of the deployment workflow. Suppose you want to deploy GLOSA in your city and you don't have anything yet related to the service. Then the first part is to look how the traffic light controllers can be interfaced. So what is really required is at least the current state of the traffic lights and a prediction when the light changes. That would enable the advice the yellow car got. And we can assume that when the queues are not too long, road users can kind of adapt to the queue that is in front of them. But what would be much better, of course, is if there is a queue length available, or when that's not the case, we can also use detector states to model the queue ourselves in the roadside unit. The problem here is that those interfaces are often vendor specific, so even in the same country, there are different vendors that have different kinds of interfaces to get this data. And between European countries, the interfaces are often different as well because of national standards for this. What is also possible is to interface directly with the traffic management central when there are more or less fixed time controllers. Then often these centrals also have this data available. For the Netherlands, this is not the case, but I've heard that in the USA, for instance, there are some traffic management centrals that basically know everything about the state of the traffic lights in the entire city. So that would be a very cheap option to directly get all data of an entire city. So basically, if there is nothing yet and the interfaces are not known, the start to deploy is to develop a new interface to get this. But that means that once this is developed, all traffic light controls of the same type can directly be interfaced. Then on the next slide, we have some next step. So we get this data now, but we still have to tell the system where this data is located, and later on the app also needs to know where the vehicle is and match the vehicle's position to the data. So we see a picture in the middle that is a schematic overview of how an intersection approach could look like. The yellow arrow is basically what we are most interested in. This is like a path that says, well, if you are on this path, then you belong to the signal groups that are the red lines on the right of the picture. So for instance, there is a signal group for the right turn, 2 lanes for through, and 1 signal group for left, and they all belong to this yellow approach path. And in the configuration, we just need to tell the GPS coordinates of this path and which signal groups belong to this path. So this is contained in the map message, and then the dynamic data, which only links to the signal group numbers, is contained in the spot message. On the next slide, we see the back office configuration. This is to distribute the data through the internet to the right vehicles. So in order to prevent vehicles in Spain from getting data from Dutch intersections, we draw a circle around the intersections to indicate a geographical relevance area. The standards allow for different kinds of shapes. So in theory, you can make any exotic location that you can think of, like polygons. They basically give you lots of possibilities. But of course, we also have to take into account that GPS is not 100% accurate to the centimeter. So usually it's best to just draw a circle around the center of the traffic light controller and say within 500 or 1000 meters the data should be sent there. Then the connection to the roadside units, that one should be, of course, secure, because the roadside units are connected to the real traffic light controller. So this is a really important point why we separate these back offices and have this interface and don't directly connect from a roadside unit to an individual car user, because we don't want this individual car user to be able to hack into the traffic lights. And this is also something MOBiNET helps us with, because the structure of MOBiNET is also secure and only aimed at distributing data and not a full connection between all the components. Then also in the back office for the MOBiNET platform, there is a service description. And basically the service description only has to tell us how to reach the data and where the data is available. And this is for other services to see if they can do something with this data. So basically there is no location-specific configuration other than the location itself in this data. So this is a very easy step to publish basically the data into the platform. On the next slide, we are going in more detail for the MOBiNET platform usage. Here we see the GLOSA app on the right in the dark blue block, and we see some components it's using. So the Mobi agent is like a component that is inside a smartphone or a tablet, and it gives certain services to the apps. So the communication manager, CM, here in this figure has a connection with either an 802.11p router or a communication agent. But our app doesn't need to know how this data is flowing in. It just knows messages are flowing in. So we don't have to take into account what is the source of the data. And this is a big advantage for developers, because they don't this functionality of the communication manager, being flexible about these two data paths, only has to be implemented once. We don't have to implement this again for another app. It's still there. It's still the communication manager. And the same basically holds for the position and timing component. We don't have to take into account that on different tablets or devices this is working differently. We just get to the position, the GPS location, and the current time through the same interface, independent of which device this is. Lastly, there is a statistics component. Magnus and Rasmus showed a picture of all the MOBiNET platform components. This is a new component that was not in this picture yet, but we believe this is important because it gives road authorities the possibility to get some statistics on how often this service actually gets used, because we plan to offer this service free of use and for the end user. So it would be very interesting for road operators, which would be the customer, to see if it actually gets used. So on the next slide, we see the rest of the MOBiNET platform and green circles around the components that are used by GLOSA. So it starts with B2B and B2C service content providers. These are all published in the service directory, which is in the MOBI Center. And it can be managed through the dashboard. And the dashboard is also where the statistics component would be. So we would be able to get usage statistics and show them to a road operator, which could be a customer. Because it's a free of use for the end user, there's no billing involved, no identity involved. I mean, everyone can use it. We don't mind your identity. And also a TSP manager we don't use. From the developer side, we of course use the SDK and MOBI agents and the communication agents. These are components that offer services that could be used by multiple services, and we use them too. Then the next slide shows where we are right now. We have GLOSA running in Helmond since release 1, which is a bit more than a year ago. And currently we are working on the Vigo test site in Spain. And there is already an existing data and service provider. And basically, we are, as IMTECH, only the app provider on this test site. And we are now evaluating the standards of these messages, which appear to be a bit different, but we can probably incorporate this as well. The last slide has some conclusions about the service. Okay, no, that was the second last slide. This is thank you for your attention. There is one before. Yeah. So we successfully deployed GLOSA within MOBiNET. And we see that the enabling of both 802.11p and internet connectivity have big advantages for us to reach a much bigger end user community. And the B2B environment, business to business environment with the service directory, we see a lot of potential here, because maybe our data can also be used for routing applications, for instance, and we would be happy to discuss with other service providers to see if parts of our service could also be used in another service. So that was it for now. Thank you all for listening. I don't know what the rest of the procedure is. Are we going to Julie now or for questions?
Thank you, Ruben. I think it's shortly back to me before we move on to Julie. Q&A we will save at the end of the webinar. So basically, you've had a high-level overview of MOBiNET, and you've been presented two very specific services that are using MOBiNET and would not be as successful as they are without MOBiNET. So then, of course, the big question is, where can I see all this? And that will be the link to you, Julie.
Yes, thank you, Rasmus. So indeed, in my presentation, I will give you an overview of all the activities where you can hear, see, and talk about MOBiNET at the ITS World Congress in Bordeaux to take place next 5 to 9 October. And before I go in the detail of one of them, that is the hackathon, so this is an overview of these different activities. You'll be able to find us at our stand and see their demonstrations of the services that were presented to you beforehand, among others. So basically, most of our services developed during the project as proof of concept, which you can read more about on our website. The ITS Hackathon, I will develop this in details afterwards. The multimodal travel assistant application that will be available as an add-in to our Congress Navigator app. a special session that will be more focused on the business aspects of a universal service platform such as MOBiNET. 10 papers, perhaps more focused on the technical aspects of the platform, but also of the service development, but some of them also focused on the business aspects. Of course, you'll get to hear about our final event that we're preparing, and that will take place at the next ITS Congress, that is the European one in Glasgow in June 2016. And you'll hear about as well the next steps, which Rasmus will touch on a bit after on, and that is how to get engaged in what's coming next, namely the provider community. So you'll be able to learn about this as well at Bordeaux, at the showcase in Bordeaux, sorry. So we are organizing among these activities, as you saw, ITS Hackathon. And this is how it's going to happen. So the hackathon is taking place from the Tuesday morning until the Thursday midday. In the morning of the first day, the participants will come and some will pitch IDs already, and based on these IDs, teams will form themselves. Some will, of course, come to the hackathon already created, and it will be the role of our mentors to help them refine their IDs, assist them in understanding and best the concepts of MOBiNET and how to include this in their developments. I will present you afterwards what is expected of them exactly in that context. So after the teams are formed and their IDs are refined, they'll start coding. They'll have the whole afternoon of the Tuesday and Wednesday all day to do that. In the Thursday morning, they'll prepare demos of what will be, of course, at the time only prototypes, concepts. They'll demonstrate this to a jury of top managers, and after the deliberation, we will announce who has won the prizes. There are two themes in this hackathon. One is the intelligent mobility, and the other one road safety. And for the two themes, there's a prize pool of 10,000 euros in prize money and an incubation package. So the most promising apps in both teams will be offered the possibility to continue their developments until they're able to demonstrate a finalized app service on the MOBiNET stand at our final event in Glasgow. This hackathon is organized by MOBiNET as well as by Michelin Challenge Bibendum, and we have sponsors as well, namely for the road safety themes with the e-safety aware research project, or European project, let's say, and ERTICO ITS Europe. So who is it aimed at this hackathon? We expect academics, startuppers, app developers, and service providers to join us and develop, well, new services and apps in either the theme of intelligent mobility or road safety, and by making use of MOBiNET in such way that they are using either our components or tools, but also the data services that they will find already registered in our service directory. They could alternatively also develop services for the platform itself. So basically services that can be used by other services and that we eventually could adopt as the platform standard features. We also asked them that they develop services with a European dimension in order to highlight, of course, the vision or the concept behind MOBiNET. And well, as Rasmus was introducing beforehand, the parking services is the parking use case is a perfect example of that, of a service with the European dimension, and that's what we are expecting from them. Registration to this event can be done at the website that you see there. On this website, you can also find all the practical information, what I presented here, but with a bit of more details, who are the judges, mentors, frequently asked questions, the exact rules for participation, etc. And of course, you can always get in touch with us via different channels and contact me. And that is all from me.
Thank you very much, Julie. We don't have so much time yet. There's so much time left, so I'll move quickly in terms of the next steps. I think what we are doing right now in MOBiNET is that we have the technical proof of concept. So we have release 3 of the software, which is quite stable. We have most services developed for purpose of validating the platform. We will be able to demonstrate in 2 weeks' time in Bordeaux a lot of the things that are ongoing. Like I said in my introduction, what we're also looking at is integrating external users, stakeholders, into the MOBiNET project. And we have several ways of doing it. One is obviously through the hackathon that Julie just presented. If you're interested in that, I can only encourage you to sign up. It's quite a fun exercise, actually, and there's a lot of enthusiastic young people who's in the room who has ideas that old people like myself would not necessarily have thought of, being stuck in the ITS and the traffic world for quite some years. So I think the ITS hackathon, or the idea of the ITS hackathon, is quite interesting. The other part is obviously our stand, where you can see all the demonstrations, and last but not least, the MOBiNET provider community that Julie mentioned before. In essence, here there are 3 things. One is, you of course, subscribe to the newsletter, follow us on the social media, etc., in terms of being kept up to date on the latest development. There's also getting a little bit more involved, in the sense that I said that our plan is really to have something sustainable that will continue to run after the project is finished. So in that, there's a lot of non-technical issues that need to be dealt with, which we are also defining within the project, and will be quite happy for people who have a general interest in this to also be included. And then finally, what we're also encouraging external parties to do is to try out the MOBiNET platform, to make their service available, to see what happens, to get involved in the sense of putting either data from content providers, public authorities, road operators, etc., into the service directorate, or publicizing your service. That, of course, is a bit closer cooperation, which we also encourage. In order to get involved, there are 2 options. Either you can find us on mobinet.eu, or you can also send me an email directly, or give me a call, and we will make sure that both questions, consideration, and active involvement is considered in the project itself. After Bordeaux, we will of course use the remaining year to finalize both the technical issues and the non-technical issues. We will have our final event during the European ITS Congress, which will take place in Glasgow in June next year. That was what we had planned from our side, and now I'd like to open the floor for questions. And I can see that there is one question that's come in, which is very, very relevant, from Andreas Schmidt. Basically, Ruben, it's a question for you regarding the 11% less CO2 emissions after the introduction of GLOSA, whether there are any available results on this in terms of how that has been achieved. I think this is very good, because in our normal sphere, in the community where we are in, we're all a bunch of engineers, and we love to get stuck in the algorithms and in the technical details of how we're actually developing all of this. And sometimes we do forget a little bit that the most important aspect is not always the technical bits and pieces, but it's the outcomes, it's the benefits. So I don't know, Ruben, if you have a bit more information in terms of how the 11% less CO2 emissions has been reached.
Yes, of course. I have to say that I don't see the question, but I heard it from you, so that's, I guess, enough. There was this project Contrast. In the beginning of the presentation, I showed you those 3 pictures about the algorithm. So with Q estimations, it works better, and that was also what was used in this project. And in this project, we had a field trial with around 100 people driving around for, I believe, 3 months. And 1.5 months they were without the system to see their normal behavior, and then 1.5 months with the system to compare on how much their CO2 emissions decreased. So that's basically how this was done.
Do we have a report that we can make available on this, Ruben?
Yeah, there's a paper. I don't know the citation by heart, but I can send this to you so you can add it to a follow-up email about this session.
Excellent. We will definitely do that. Thank you, Ruben. Now, the next question that came in is from Enrique Pindado. Apologies if I don't pronounce the names correctly. Basically, he's asking, does MOBiNET have plans for 2-wheeler services, or if there is any demo cases on this? It's not something that we have specifically within the use cases that has been developed, but that does not mean that it's been ruled out. Basically, anything related to mobility in general goes in this context. And that's also why we have the hackathon itself. As you know, these things, we have limited resources. We have to focus on some of the specific services that the consortium already are working on or has knowledge on. And unfortunately, mobility services for 2-wheelers was not included in the original selection of use cases in MOBiNET. But I have no doubt that there are a lot of opportunities for also doing this, and it could be a very interesting aspect to look at during the ITS Hackathon in Bordeaux. I think that was it related to the questions. If there is nothing else on the screen now, you have our contact details. We will, of course, make presentations, including the paper from Ruben on the 11% CO2 emissions, make that available to all of you afterwards. And like I said, feel free to contact us if you have any questions, but even better, if you are going to be in Bordeaux, come around the stand, B95 in Hall 1. In hall 1, and we can give you a demonstration. And if you are interested both looking at what we're doing and also a bit thirsty at the same time, I'd recommend Tuesday at 5 o'clock, where we do serve a small glass of wine. So with that, thank you everyone for participating. Thank you to our panelists today. Thank you, Maria, for setting everything up. And I wish you all a very good Monday. Thank you. Goodbye.
Thank you, Rasmus. Bye.